Today, while playing around with prompt engineering, I thought to myself, it would be very helpful to know how LLM is paying attention to different words, right? I wonder if I knew how the LLM attention mechanism works, would it make me a better prompt engineer? Would it improve my skills at prompt engineering, right? And I wonder about that because I've been playing with Cloud Sonnet, OpenAI, Llama, and I've gone through their prompt instruction manuals, right? And each one of them, they have their different ways and different suggestions around how you should structure your prompt. And that's when I started wondering, okay, given any model, how can I figure out which words are being attended to, which words are being focused on, what would be a good length of prompt, and how does it vary from one model to another model, right? And this is when I decided, at least let's scrape through this paper called Attention is All You Need, which is when the transformer architecture was first introduced. So here it goes. The paper starts with an abstract. It says the dominant sequence transduction models are based on complex recurrent or convolutional neural networks that include an encoder and decoder. Now, please understand that I don't have any background in machine learning or AI. So, for me, all of this is a complete bouncer. The dominant sequence transduction models are based on complex recurrent or convolutional neural networks that include an encoder and decoder. The very first question I had was, what is a sequence transduction model? I looked it up, and this basically means a neural network that can take a sequence as input and convert that sequence into a different sequence as an output. One of the natural application of that is converting a English sentence into a French statement, right? Sentence. An image is also a sequence of pixels, right? Converting an image and captioning it, so basically converting it to a text sequence, is also a sequence to sequence transformation, right? And this is called transduction. Now, this is what it means. The dominant, so when the paper was written in 2017, the dominant sequence transduction models are based on complex recurrent or convolutional neural networks, which are kind of different types of neural networks that include an encoder and decoder. We don't know what that is yet, but okay, encoding and decoding these two sentences kind of make sense, right? But we'll revisit them. And then there is this curious statement. It says the best performing models also connect the encoder and decoder through an attention mechanism. And at this point, I'm like, okay, I used to think that this is the first paper. The attention is all you need was the first paper which introduced the concept of attention. Turns out I was wrong. That it was a misconception. Clearly, this statement implies that the concept of attention existed even before this paper. And then the paper goes on saying, the abstract goes on saying, we propose a new simple network architecture, the transformer, based solely on attention mechanisms, dispensing with recurrence and convolutions entirely, which means that this new neural network is not a RNN or CNN. It is called a transformer for some reason, and it is completely based on attention mechanisms. Um, and then the paper goes on giving some examples and benchmarks by saying experiments on two machine translation tasks show these models to be superior in quality while being more parallelizable and requiring significantly less time to train. Our model, the transformer, achieves 28.4 BLEU on WMT 2014 English to German translation tasks. Seems like this is some kind of evaluation framework or evaluation mechanism where we can evaluate the efficacy of a model. Okay. And then they go on saying we show that the transformer generalizes well to other tasks by applying it successfully to English constituency, parsing both with large and limited training data. Now I don't fully understand this, but where my attention was when I was reading this was the best performing models also connect the encoder and decoder through an attention mechanism. And at this point, I started researching what were some of the first papers which introduced the idea of attention and what was the inspiration and what are some of the implementation details, right? So one of the first paper which introduces this idea is neural machine translation by jointly learning to align and translate. So we open this paper. This paper is available on arxiv.org. So again, the paper name is Neural Machine Translation by Jointly Learning to Align and Translate. Now let's read the abstract of this. I'm going to try and read all the full paper, but I don't really have big hopes on understanding everything. I just want to train my neural network right now for these words and dictionaries, so that over next few months I can build some idea in my head as to what those words mean. So let's read the abstract. It says neural machine translation is recently proposed approach to machine translation. Unlike the traditional statistical machine translation, the neural machine translation aims at building a single neural network that can be jointly turned to maximize the translation performance. Okay, so it seems like before this paper was published, the traditional way was to use statistical machine translation, and the approach that the authors are proposing is the neural machine translation. Now they go on saying the models proposed recently for neural machine translation often belong to family of encoder, decoder and encoder the family of encoder and decoders, and encode a sequence of sentence into a fixed length vector from which decoder generates a translation. Now at this point I think the encoder's main job is to create a fixed length vector. Now I don't know whether I'm correct, but we'll only find out. The models proposed recently for neural machine translation often belong to a family of encoder decoders and encode a source sentence into a fixed length vector from which a decoder generates a translation. In this paper, we conjecture that the use of fixed length vector is a bottleneck in improving the performance of this basic encoder decoder architecture, and propose to extend this by allowing a model to automatically soft search for parts of the source sentence that are relevant to predicting a target word without having to form these parts as a hard segment explicitly. Very complicated statement. but what I understand from this is, um, now the first thing, see, they say in this paper we conjecture that the use of fixed length vector is a bottleneck in improving the performance of this basic encoder decoder architecture. Now, what do you mean by performance? Now, I come from a web development background, right? So, or if you come from a DBMS background or some other normal software engineering background, it generally would mean the response time for us, right? If the response time is faster, the performance is if the response time is less, the performance is better. But I don't think here the word performance is the performance refers to response time, and not only the response time. It's probably also the quality of translation. But again, we'll only find out when we go ahead. Um, so again, in this paper, we conjecture that the use of fixed length vector is a bottleneck in improving the performance of this basic encoder decoder architecture, and propose to extend this by allowing a model to automatically soft search for parts of source sentence that are relevant to predicting a target word. Um, Here I don't know what they are trying to say by saying automatically soft search for parts of source sentence that are relevant to predicting a target word without having to form these parts as a hard segment explicitly. I think what soft search for parts of sentence hints towards attention, right? If there is a statement that I ate an apple, where should your attention be if you are going to translate this, right? Obviously, I ate an apple. All of them are important, um, because the statement is really small. But your attention would be on the object, which is apple, subject, which is I, and ate. But ate is not just a simple word, right? It also is an action that happened in past. But I don't know whether the attention is supposed to consider all of that. So we'll see. With this new approach, we achieve a translation performance comparable to the existing state of art phrase based system on the task of English to French translation. Okay, so they are not saying that the performance exceeds the current state of the art phrase based systems. They are saying that they are able to achieve this. Furthermore, qualitative analysis reveals that the soft alignments found by the models agree well with our intuition. Okay, I don't know what that means. Introduction. But let me read through this and then let's see if I can summarize something.